Recording will start. Okay. Today we will discuss about new topic, superposition of waves. Superposition of waves. What is wave? Wave is simply an oscillatory disturbance traveling through a medium. There are two types of waves, transverse waves and longitudinal waves. Okay. Here, other category, that is progressive wave. Okay. So today we will discuss about different physical characteristic features about the wave nature. Okay. Progressive wave. Progressive wave are waves which progressive waves are waves which continuously traverse in a given direction. Okay. The particles of the medium start vibrating about their mean position when these waves start traveling through a medium. If these vibrations are simple harmonic vibrations, the waves are called simple harmonic progressive wave. What is progressive wave? Progressive waves are waves which continuously travel in given direction. Okay. Then y is sine or cosine function of such wave. Then y equals to a sine of k pt minus x. What is y? Y is displacement. A is amplitude. K is wave vector. V is velocity. X is the displacement. Okay, it is called plane progressive harmonic wave. In plane progressive harmonic wave, oscillations of y are simple harmonic in nature. Okay, the quantity k has special meaning. Replacing the value of x by x plus 2 pi upon k, we get the same value of y, and that means y equals to a sine of k mu t minus x plus 2 pi upon k. Okay, this quantity 2 pi upon k equals to lambda, designated as wavelength, is the space period of the curve. That is, the curve repeats itself by every length lambda. What is important? Important is this particular equation, that displacement of a particle which is in motion associated with wave is given by y equals to a sine of k mu t minus x plus 2 upon k. And progressive waves are which continuously travel in given direction. Next one, the quantity k equals to 2 pi upon lambda represents the number of wavelength in the distance of 2 pi and is called wave number. Okay, so wave number k equals to 2 pi upon lambda. Y equals to a sine k mu t minus x represents a plane progressive harmonic wave of wavelength lambda propagating towards the positive x-axis with speed v. The above equation can also be written as y equals to a sine omega t minus kx plus phi, where omega is angular acceleration equals to k into mu equals to 2 pi mu upon lambda. Here k equals to omega upon mu, that is omega equals to 2 pi mu, and V equals K equals to omega upon mu. But what is K? K already defined is 2 pi upon lambda. And phi is the phase constant or initial phase of the wave. Further, if f is the frequency with which y oscillates at point x, we have the important equation. What is that? V equals to n lambda. Velocity of a particular wave equals to frequency into its wavelength. Okay, V equals to n lambda is true for both transverse waves and longitudinal wave. Okay, what is V? Velocity, velocity of the wave, n frequency, and lambda, lambda is the wavelength. Also, if t is the period of oscillation, then t equals to 2 upon w. Okay, because already we have defined with t equals to 2 pi r upon v. Okay, so same we have written in terms of uh, 2 pi upon w. 2 pi r upon v same as 2 pi upon w. We may also write y equals to a sine of 2 pi t upon t by just having the substitution minus x upon lambda. So you have to remember this equation, also this equation while solving the problems. Okay, t equals to 1 upon mu. That is reciprocal of the frequency equals to time period of the oscillation. Okay, this is the equation of plane progressive wave. What is that? Y equals to a sine 2 pi t upon t. What is this t? Is the time for which the wave is traveling. This t is time period minus x. X is the extension or the displacement, and lambda, that is wavelength. This is the equation of plane progressive harmonic wave. If the wave is traveling in the direction of negative x-axis, then y equals to a sine 2 pi t upon t plus x upon lambda. Next, what is principle of superposition of waves? Yesterday we have talked about interference phenomena, that light plus light is either maxima of intensity or minima of intensity. Okay, so depends on, or it simply follows superposition theorem, and that phenomena is called interference. It states that when two or more waves traveling through a medium arrive at a point of the medium simultaneously, each wave produces its own displacement at that point independent of the other. Means here, as per the principle of superposition of theorem, we have said that y equals to y1 plus y2, where y is resultant displacement, y1 is the displacement associated with wave first, y2 displacement of wave associated with second wave, which are probably superimposing on each other. Okay, so it produces the probable displacement. It states that when two or more waves traveling through a medium arrive at a point of the medium simultaneously, each wave produces its own displacement at that point independent of the other. Hence, the resultant displacement at that point is equal to vector sum of the displacements due to all the waves. Y equals to y1 plus y2. Okay, these are the displacements due to individual wave, and y is the net resultant displacement. Okay, so due to the superposition of waves, we are getting different phenomena such as interference, production of waves, and production of stationary waves, and each is having its own importance. So yesterday we have talked about this interference phenomenon. two waves having constant phase difference, where phi is constant, produces interference, right? How waves are produced? Two sound waves having slightly difference in frequencies. Okay, so if frequencies and amplitudes are nearly equal, okay, then they are able to produce the bits. Next, stationary waves, two waves moving in opposite direction. That is, when F1 equals to F2, means frequencies are same and A1 equals to A2. Amplitudes are also same, but they are moving in opposite direction to each other. Okay, so stationary waves are produced simply by when two waves having same frequency and same amplitude are moving in opposite direction to each other. Means if this one is the incident wave, okay, and obviously this is the reflected wave, and if we are assuming that amplitudes of both the waves are same and frequencies are also same, then it produces stationary waves. Obviously, here is the presence of node, presence of node, presence of node. Then antinodes. What it means, stationary waves consists of alternate nodes and antinodes. Alternate nodes and antinodes. Okay, antinodes. So stationary waves are characterized by alternate nodes and antinodes. Nodes are the regions where displacement or net net amplitude becomes equals to zero, and antinodes are the region where maximum displacement or maximum amplitude. Maximum displacement is simply the amplitude. Okay, so it's the region of maximum displacement. Antinode is the region where amplitude is maximum. Node is the region where amplitude is minimum. Okay. Now let us see here. This is the explanation given for the interference phenomenon. What they have assumed? They have assumed two equations in terms of x and t. Okay. So the first equation related with first wave, second equation related with second wave. When they are superimposing on each other, we get y equals to y1 plus y2. So net displacement y in terms of x and t equals to, if you're solving this equation, yesterday we solved this equation. Okay, so it reaches to 2a cos of pi by 2 sine of kx minus omega t plus pi by 2. Okay, so resultant displacement y equals to y1 plus y2 equals to a sine of omega t plus phi, where a equals to square root of a1 square plus a2 square plus 2a1 a2 cos phi, and tan theta equals to a2 sin phi upon a1 plus a2 cos phi. Okay, so based on this formula, we have solved number of examples, okay, for the interference topic. Okay. Next point, stationary waves, just now we have discussed. Consider the reflections at two or more boundaries. A string fixed at both ends or an air column in a pipe with both ends closed. Here, due to interference between incident and reflected wave, a steady wave pattern will set up on the string, which are called standing waves or stationary waves. We know that if here is the boundary, okay, and here is also the boundary. When the any type of wave, it is passing through these two boundaries. Then incident wave, this is incident wave, will be reflecting back. If trough is approaching here, then it will get converted and reflecting in terms of the crest. म्हणजे इथे इन्सिडेंट वेव्हचा क्रेस्ट बाउंड्रीवरती येत असेल किंवा ट्रफ बाउंड्रीवरती येत असेल, तर जेव्हा ही लाईट रिफ्लेक्ट होते तेव्हा इट स्टार्ट्स फॉर द क्रेस्ट ऑफ अनदर वेव्ह. ओके, इथे क्रेस्ट असेल, इथे ट्रफ असेल, तर त्याप्रमाणे ही रिफ्लेक्टेड वेव्ह तुम्हाला अपीयर होताना दिसते. ठीक आहे. So this is incident wave and this one is reflected wave. This is the crest of second reflected wave and this is the trough of incident wave. This is incident wave and this is reflected wave. So here you can observe here uh, here there is trough and trough is coinciding with the crest of reflected wave. Okay, and this region at which the maximum displacement of the particle is taken place, that region is called antinode. Antinode. Okay, and this is the location at which the net displacement of particle becomes almost equals to zero. So that is called node. Okay, if y equals to y1 plus y2, then a into sine of kx minus omega t plus a sine of kx plus omega t. Because incident wave and reflected wave are moving in opposite direction to each other. Condition for node. Which region is called node? Node is where amplitude equals to zero. Amplitude equals to zero. In this particular stationary wave, we find here is node, here is node, here is node. So 3 nodes and 2 antinodes will be observed. 3 nodes and 2 antinodes will be observed in one stationary wave. For nodes, the amplitude is zero. This offers the values of kx that gives rise to sine of kx equals to 0. And sine of kx equals to 0 will get satisfied for kx equals to 0 or plus or minus n pi. Okay, so it is a condition kx equals to n pi and therefore x equals to n pi upon k. X equals to n pi upon k. Okay, so for nodes we are having this equation x equals to n pi upon k. Okay, putting k equals to 2 pi upon lambda. Substitute k equals to 2 pi upon lambda. So n pi upon k equals to 2 pi upon lambda. So equals to n pi lambda upon 2 pi. Okay, I will get cancelled. So what is this? X is the distance in between two successive nodes. Distance in between two successive nodes. So first node, pi will get cancelled. So if we are putting n equals to 1 for calculation of x value, x is the distance, okay, distance from one node to another node, or so what you are getting, x equals to n lambda upon 2, n lambda upon 2. For n equals to 1, that is first node, x equals to lambda by 2, x equals to lambda by 2. So this distance in between two successive nodes equals to lambda by 2. Okay? And distance in between this node to this node, it is coming as lambda. Okay? So for nodes, we have written here x equals to lambda by 2 and so on. Next. So first node is formed at x equals to, first node is formed at x equals to lambda by 2. That you remember. Then conditions for antinodes. For antinodes, for the condition, we have to accept kx equals to n minus half into x. Okay, and therefore x equals to 2n plus 1 into lambda by 2, where n equals to 0, 1, 2. If you are taking minus sign here, then your n should start from 1, 2, and so on. Thus, amplitude of wave will be maximum at the position of string given by above equation. The first maximum amplitude will occur at x equals to k by 4. The second maximum amplitude will be at x equals to 3 lambda by 4. Here, this is 0 when the wave starts its motion. This is one complete oscillation will get covered by the phase difference of 2 pi, and 2 pi corresponds to lambda. 2 pi, that is phase difference, 2 pi corresponds to lambda. Okay? So how much is this distance? This distance is 2 pi corresponds to lambda. Means this complete distance is lambda. Okay? And it is at the half. So first node is observed at the distance of lambda by 2, and again half of that. So first antinodes will be observed. First antinodes will be observed at the distance of lambda by 4. Okay, this is lambda by 4. This one is lambda by 2. Again here 3 lambda by 4. Here 3 lambda by 4. And here is complete, that is lambda. Okay, so nodes are appearing at the distances of integral multiple of lambda by 2, whereas antinodes are observed at the distances of lambda by 4, 3 lambda by 4, and so on. Okay, but distance in between two successive nodes and antinodes, it is remaining same, that is lambda by 2. Next, there are two cases: string fixed at both ends and string fixed at one end. One end is open, other end is closed, and here string is fixed at both the ends. Consider a stretched string having length of L. You can find here. This is straight string having length L, fixed at both the ends in such a way that one end be at x equals to 0 and another end is x equals to L. These are the two contact conditions where this straight string is observed. Okay? Then total distance. This total distance is from x equals to 0 to x equals to L. These are two boundary conditions. Has been that this L equals to n lambda upon 2. Okay, n equals to 1. Then L equals to lambda by 2. Similarly, lambda equals to 2L upon n, where n should start from 1, 2, and 3. Then frequency of vibration, nu equals to nv upon 2L. Nu equals to nv upon 2L, because lambda equals to 2L. Okay, frequency of vibration. It follows simple equation. V equals to n lambda. If n is replaced by nu, then it becomes velocity equals to nu lambda. V equals to nu lambda. Okay, V equals to nu or n lambda. For what is lambda? Lambda is simply n upon 2L. Okay? So n upon 2L square root of T upon mu. What is V? V is square root of T upon mu. Mu is what? Mass per unit length. Mass per unit length of the string. ठीक है. So lambda equals to frequency of vibration equals to frequency of vibration can be given in terms of V equals to nu lambda. Okay, nu equals to V upon lambda. But what's lambda here? Lambda from this equation is 2L upon N. So yes, correct, right? V equals to nu lambda. Nu equals to V upon lambda. Okay, but what is lambda? Lambda equals to 2L upon n that we have substituted. So we are getting the expression nu equals to n upon 2L square root of t upon nu. This you have to remember. And lambda equals to v upon nu. Here v is speed of the wave and t is tension in the string and nu is mass per unit length of the string. Now string fixed at this case for string fixed at both ends. Now let us see for string fixed at one end and other end is open end. Okay, so in that case, how that value is changing? It changes as nu 0 equals to nu v upon 4L. Okay, just here sign of KL equals to plus or minus 1. So KL equals to 2n plus 1 into pi by 2. Therefore, here frequency of vibration u equals to 2n plus 1. इथे काय होतं? Frequency of vibration when string is fixed at both the ends, it is simply nv upon 2l, nv upon 2l. And how it is modified here? Frequency of vibration nu equals to 2n plus 1, okay, upon 4l into v. Okay, but for the straight string, v equals to square root of t upon mu. Okay, v equals to square root of t upon mu. So frequency for the first mode of vibration, f equals to here is frequency. Frequency is equal to n upon 2L square root of t upon mu. Whereas in this case, the same equation we can write as n upon 2L. N is to be replaced by 2n plus 1. 2n plus 1 upon 2L into square root of t upon mu. Okay, next. First mode of vibration, length. The mode of vibration in which string will vibrate with natural frequency, that is called fundamental frequency. So lambda equals to 2L upon n, that is for first harmonic. L equals to lambda by 2. Okay. Second mode of vibration, simply n has to be substituted by n equals to 2. So L equals to 2 lambda upon 2. N equals to 2, L equals to 2 lambda upon 2. ठीक है? So nu equals to nc upon 2L. For n equals to 3, the frequency of vibration nu equals to 3v upon 2L. 3v upon 2L. It is called third harmonic and so on. If you are substituting n equals to 1, you will get fundamental mode of vibration. N equals to 2, we will get second mode of vibration. N equals to 3, we will get the third mode of vibration. Okay? Now, if n equals to 3, the frequency is 3, nu equals to 3v upon 2L. Or v equals to, see here, frequency is given by nu. In some of the books, frequency is denoted by n. In remaining books, frequency is denoted by f. F, N, nu. हे जे काही notations आहेत ते frequencyसाठी. Okay, so this is the frequency. Frequency equals to 3V upon 2L, right? But V upon 2L, V upon 2L. So that is nu1. Okay? And therefore, for n equals to 3, nu equals to 3 times fundamental mode of vibration. So it is shown as shown in figure. This is the fundamental or first harmonic, where this total length is L. Okay, and here you can observe L equals to lambda. Maximum displacement is observed. Distance in between two successive, this is node, this one is also node, so obviously distance in between two successive nodes is lambda by 2 and so on. Okay, so here is the fourth harmonic, where 1, 2, 3, 4, and 5. 5 nodes, and in between each node, you will find empty nodes there. 1, 2, 3, and 4. So stationary waves are characterized by alternate nodes and antinodes. So depends on that, you are able to calculate first harmonic, second harmonic, third harmonic, and so on. Okay. Next, these are some equations you have to remember. Next, laws of vibrating string. The fundamental frequency of a vibrating string under tension T. Let us suppose this one is a vibrating string of length L. The fundamental frequency of a vibrating string under tension T is given by nu equals to 1 upon 2L square root of T upon mu. Nu equals to 1 upon 2L square root of T upon mu. From this formula, three laws of vibrating string can be given as follows. Which is the first law? Frequency of the vibrating string is inversely proportional to vibrating length of the string. Nu is directly proportional to 1 upon vibrating length. That is first law. Second law, the frequency of the uniform string of given length is proportional to square root of tension in the string. And third law, obviously, what will that? From this formula, it is very clear that mu is inversely proportional to length, vibrating length of the string. First law. Second law, mu is directly proportional to square root of T. And third law, mu, that is frequency of vibrating string, is frequency of vibrations along the length of the string, is inversely proportional to square root of mu. What is mu? Mu is simply mass per unit length of the string. Mu is mass per unit length of the string. It is written. Mass per unit length of the string is called mu. Okay? So these are three laws. And all these three laws can be proved with the help of one of the instruments that is called sonometer. Okay? Now study of vibrations of air column. Okay. For fundamental mode, there are two cases, closed organ pipe and open organ pipe. We have seen that if L is the length of a string, then first antinode will be observed at the distance of lambda by 4. First node will be observed at the distance of lambda by 2, because these waves are having same frequency, same amplitude, which is simply reflecting back from the denser medium, like this. Okay, so incident wave and reflected wave are suffering the phase change of pi radians. Phase change of pi radians. म्हणजेच काय, जर इथे डेन्सर मीडियम असेल आणि ही अशी वेव्ह ते प्रोपगेट होते, ही इन्सिडेंट वेव्ह आहे. ओके, तर ती इथून रिफ्लेक्ट होणार आणि रिफ्लेक्ट होत असताना इथे समजा तुमची बाउंड्री असेल, सपोज हिअर इज द बाउंड्री. So when this wave is going to be incident at this surface, then reflected wave will suffer the phase change of pi radians, and therefore reflected wave will propagate by changing. एक मिनिट हा, एक मिनिट. अशी केस आहे, इथे वेव्ह स्टार्ट झाली सपोज, ठीक आहे, इथे वेव्ह स्टार्ट झाली, इथे इथे येऊन पोचली. इथे समजा मॅक्सिमम ॲम्प्लिट्यूड आहे, मॅक्सिमम ॲम्प्लिट्यूड दॅट इज क्रेस्ट. तर रिफ्लेक्टिंग सरफेसवरून ते क्रेस्टचं कन्व्हर्जन ट्रफमध्ये होतं आणि क्रेस्ट आणि ट्रफ ह्याच्यामध्ये फेज डिफरन्स कितीचा असतो बघा. दिस इज वेव्ह 0, 2 pi, here is pi, here is pi by 2, and here is 3 pi by 4. 3 pi by 4. And this is crest, this is trough. And phase difference in between crest and trough. Crest and trough equals to pi. Pi is 180 degree. Okay? So, okay. Next, there are 2 points, free vibrations and forced vibrations. This is required in order to study the resonating tube experiment based on resonance. So, free vibrations, when a body is displaced from its equilibrium position and released, the restoring force acting on the body may set the body into vibration. Such vibrations are called natural or free vibrations. Okay, if the body is vibrating with its natural frequency, then it is associated with free vibrations. If the body is vibrating by just applying some external forced vibrations, okay, when a body vibrates under the influence of an external periodic force, then the body is said to be under the forced vibrations. Okay? Examples, forced vibrations produced by vibrating tuning fork in an air column. The oscillations of a simple pendulum. Next, this is the resonance tube, where we can find if we are applying applied force equals to natural force, or when the body is vibrating with its natural frequency, and when the natural frequency is completely balanced by the applied frequency, then we can find the resonance is taking place, and at the resonant condition large sound is going to be produced. Okay. Next, what is the concept of beats? When two sound waves of nearly same frequency are produced simultaneously, then the intensity of resultant sound wave increases and decreases with time. This phenomenon of change in the intensity of sound is called beats. The time interval between two successive beats is called beat period, and the number of beats per second is called beat frequency. If F1 and F2 are the frequencies of the two waves, then the beat frequency F equals to F1 minus F2. Okay? Then some calculation of beat frequency. So frequency is equal to 1 upon periodic time. Here reciprocal of beat period is that beat frequency 1 upon T. Okay? Then applications of beats. Tuning of musical instrument is done by noting beats produced. The phenomenon of weights is used to determine unknown frequency, then to detect the presence of harmful gases like methane in mines. Few applications are mentioned. Then this the instrument used to do the three laws, sonometer. Now let us see by considering all this. Now we have to start to solve the examples. So the fundamental law V equals to n lambda, this you should know. V equals to n lambda. What is V? Velocity, n frequency, lambda, wavelength associated with the propagating wave. That is fundamental. Then fundamental frequency of the vibrating string is given by n equals to 1 upon 2L root of T upon mu. Okay. Then third equation that L equals to n lambda upon 2. Then fourth equation that is associated with beats F equals to F1 minus F2. They are the fundamental equations. Along with we should have the fifth equation that y is equal to a sine of 2 pi t upon t minus x upon lambda. Okay? Equation associated with the progressive wave. Now, let us see the first example. Extension in a wire obeying Hooke's law. What is Hooke's law? Tension in the string. Hooke's law says that tension in the string is directly proportional to extension. Extension, that is x. Okay? Tension in the string is directly proportional to extension in the string. And also we know that P equals to square root of T upon n. Square root of T upon n. Velocity equals to square root of tension upon mass per unit length. So V equals to square root of T upon m, mass per unit length, and T is the tension. Obviously, extension in a wire obeying Hooke's law is x. The speed of sound in the straight wire is v if the extension in the wire is increased to 4x. Okay, increased to 4x, then the speed of sound in a wire. What is the formula? V equals to square root of T upon m. That means V is directly proportional to square root of T. But T is directly proportional to extension, and therefore, if you are saying V is directly proportional to T, first equation, then V dash equals to, V dash is this, the speed of sound in a wire when tension is increased to 4x. Okay? So, V dash is directly proportional to T dash. V is directly proportional to square root of T. V dash is directly proportional to square root of T dash. But if you are saying T is directly proportional to X, then obviously if you are taking the ratio of 1 and 2, then it will become V upon V dash equals to square root of T upon square root of T dash equals to, what is T dash value? T dash equals to 4 times x. T dash equals to 4 times x. So square root of T upon square root of 4x. Okay? We require to calculate the value of V dash. So taking the reciprocal. So V dash upon V equals to square root of T equals to x is directly proportional to x. Okay? So V dash upon V equals to what we can say, that is 4x upon square root of x equals to v dash upon v. Therefore, v dash upon v equals to square root of 4 upon square root of 1, and square root of 4 is 2, and therefore v dash equals to 2 into v. V dash equals to square root of, v dash is equal to 2 into v. And so this is the correct answer. What you have to remember? You have to remember these roots now. And what you have to remember? Velocity equals to square root of v upon m. M is mass per unit length. Okay? So while taking the ratio, this m will get cancelled. We have to substitute here d dash equals to 4x and t equals to t. And therefore, we are getting relation v dash is equal to 2v. That's it. So next one. Two identical strings of length L and 2L vibrate with fundamental frequencies n Hz and 1.5 m Hz respectively. The ratio of tensions for smaller length to large length. Let us suppose that there are two lengths. First one L1 equals to L and second L2 equals to 2L. L2 equals to 2L. There are two lengths. And for L1 equals to L, what is the fundamental frequency? Fundamental frequency is F1. F1 equals to n Hertz. N Hertz. And F2 equals to 1.5 into n Hertz. This is given data. There are two strings. L1 equals to L, L2 equals to 2L. That is only the difference. Where the frequency is n Hertz and F2 equals to 1.5 Hertz. And what they're asking to calculate the ratio of tensions for smaller length to large length. Means what you would find? You would find T1 upon T2. Because here T1, that is length associated first, T2 length associated with second, T1 upon T2, that you would find. What we know? We know that F equals to 1 upon 2L root of T upon M किंवा mu काही करू शकतो. F equals to 1 upon 2L root of T upon M. Now, from that you can write two equations. One is for first length, other is for second length. F1 upon F2 is equal to 1 upon 2L1, 1 upon 2L1 into square root of T1 upon M. Okay. Then second equation, 1 upon L2 2L 2 into 2 times L 2 times L square root of T2 upon M. Okay. So by observing this, what you could write, that is simply F1 upon F2 equals to square root of T1 upon T2 into L2 ची value किती आहे? L2 equals to 2L. L2 equals to 2L, and L1 equals to L. L2 equals to 2L, L1 equals to L. Okay? And what is the ratio? F1 upon F2. F1 is n hertz and F2 is 1.5 hertz. 1.5 of n. 1.5 of n. N upon 1.5 times original. So equals to square root of T1 upon T2. LL will get cancelled, so into 2. Therefore, N and S get cancelled. So obviously, yes. So square root of T1 upon T2 equals to 2 times 1.5. By solving this, square root of T1 upon T2 equals to 2 into 1.5. This 2 will go to this side. So, yes, I'm sorry. There is correction. So, square root of T1 upon T2, this 2 will go to this side. So, obviously, it will be 1 upon 1.5 into 2 equals to 1 upon 3. Okay. So, taking square root on both the sides, sorry, taking square on both the sides will get the relation in between the two tensions T1 upon T2 equals to 1 upon 9. Okay? So T1 is to T2. T1 is the tension associated with smaller length, and T2, there is tension associated with larger length. So T1 is to T2 is to equals to 1 is to 9. Okay? Next. An open organ pipe and closed organ pipe have the frequency of their first overtone. An open organ pipe and a closed organ pipe have the frequency of their first overtone identical. Okay? When frequency higher than fundamental frequency, higher than fundamental frequency of sound waves is known as overtone. For open organ pipe, for open organ pipe, first overtone can be written as, for open organ pipe, first overtone can be written as 2T upon 2L for open organ pipe equals to P upon length of open organ pipe. This is called first equation. Second equation, for closed organ pipe, mu for closed organ pipe equals to 3P upon 4L C. Length for closed organ pipe. Okay. It is given that first overtones are same. Means new open and new C are same. Therefore, if we are seeing this as equation number 2, then nu for open organ pipe equals to nu for closed organ pipe. Therefore, we can write V upon L for open organ pipe equals to 3V upon 4 times length for closed organ pipe. Okay. And therefore, we can write here V 3V upon take a minute, huh? If you are solving this, then we require to calculate L for open organ pipe upon L for closed organ pipe equals to काय होतं Vला V कॅन्सल होतं इथे आणि हा L फॉर ओपन ऑर्गन पाईप इथे गेला L फॉर ओपन ऑर्गन पाईप अपॉन length for closed organ pipe will become as 4 by 3. 4 by. So an open pipe and closed organ pipe have the frequency of their first overtone identical. The ratio of length of open pipe to that of closed pipe. Length of open pipe to that of closed pipe is equal to 4 by 3. So that's the correct answer. Okay. So these formulas you have to remember. आता इथे ना इथे कन्फ्युजन होऊ शकतं इथे न्यू इथे फी दिस फी इज वेलोसिटी दिस न्यू इज फ्रिक्वेन्सी तर ह्या नोटेशन्स तुम्हाला लक्षात ठेवायचे नेक्स्ट fundamental frequency of a closed pipe. Fundamental frequency of a closed pipe is 400 hertz. Okay. Closed pipe. What is the formula? Just now we have seen mu equals to mu for closed pipe equals to fundamental frequency. It's not first overtone. Okay, it's a fundamental frequency and fundamental frequency equals to V upon 4L. V upon 4L. And how much it is? It is simply 400 hertz. If 1/3 of pipe is filled with water, okay, if that pipe is filled with 1/3 filled with water by 1/3 of its capacity, then the remaining length of air column will be L minus 1/3. Remaining length will be L minus 1/3. So it will be 2L upon 3. So if you are calling this as first expression, now second one, L minus 1/3. If the pipe is filled with 1/3 of the original capacity by water, then L minus 1/3 equals to 2L by 3. Now fundamental frequency, you have written fundamental frequency F equals to, what is that formula? V upon 4L. V upon 4L. Okay. So it will be V is simply, what is V from this formula? V equals to 4L. This is V. V equals to 4L into frequency, that is 400. Okay. And again, if you are substituting this, V equals to 4L into 400. Then what you'll get here, F equals to 400 into 4L V value upon 4. आता Lची व्हॅल्यू कशी चेंज झाली आहे तर Lची व्हॅल्यू L minus 1/3 ने चेंज झाली. That is 2L upon 3. 2L upon 3. So that will substitute 2L upon 3. ठीक है. L is changed as 2L upon 3. And after solving this, it can be written as 3 into 400. This 3 will go in the numerator. 3 into 400 into 4 upon 3 into 400 into 4 upon 4 into 2 into L, and here is also the value of L. That L cancels with this. So remember that is 3 into 400. So 12 into 400 upon 8. Okay? So it will appear as 1800. So obviously frequency will change to 1800 Hertz. Original frequency किती होती 400 होती. जर पाईप अपॉन 1/3 ने कमी केला म्हणजे फिलिंग त्याचं, if 1/3 of the pipe is filled with water, then the frequency of second harmonic of the pipe will be. ठीक है. So it is given as F equals to 18,000 Hertz. Next. Next point, read this example. In a fundamental mode, the time required for the sound wave to reach up to the closed end profile pipe filled with air is p seconds. The frequency of vibration of air column. What you have to calculate here? You have to calculate the frequency of vibrations of air column. Okay? As we know that fundamental frequency of a closed organ pipe is given by nu c, frequency, fundamental frequency for a closed organ pipe equals to V upon 4L, where V is velocity, L is length of the pipe, and this nu is frequency. Again, we know that because here is T is mentioned, we know that V equals to L upon T, right? V equals to L upon T. Therefore, V equals to distance traveled per unit time. So T equals to L upon V. Okay? Call this as first expression, this one is second. Now, we have to calculate frequency of vibration of air column equals to 1 upon 4. What is V? V equals to L upon T. V equals to L upon T upon L. Okay? So what you have substituted here, V equals to L by T, that is substituted, 4 is as it is into L. So what is the frequency of vibration? That is simply 1 upon 4 into T. Okay? So frequency of vibration equals to 4T raised to -1. So this is the value. 40 raised to -1. That's the answer. Okay? So 40 raised to -1. So frequency of vibration of air column is 40 raised to -1. म्हणजे हा -1 हा कुठे पाहिजे आपल्याला, तर तो वरती पाहिजे. ठीक आहे. नेक्स्ट, the fundamental frequency of sonometer wire increases by 9 hertz. Okay, and if its tension is increased by 69%, keeping the length constant, the frequency of the wire, how much it will be. म्हणजे असा कन्सेप्ट आहे की फंडामेंटल फ्रिक्वेन्सी ऑफ वायर जेव्हा आपण 9 हर्ट्सनी इन्क्रीज करतोय आणि त्याच वेळी त्याचं टेन्शन सुद्धा 69%नी इन्क्रीज करतोय, पण लेंथ ऑफ द स्ट्रिंग इज कॉन्स्टंट, देन how it affects on the frequency. We have the equation for fundamental frequency. F equals to 1 upon 2L square root of T upon N. This is fundamental equation. Call this as first equation. Now the second equation. What are the changes? Changes are simply frequency is changed to F dash by simply F plus 9. म्हणजे ओरिजिनल फ्रिक्वेन्सीमध्ये 9 फ्रिक्वेन्सी 9 हर्ट्सची फ्रिक्वेन्सी त्यांनी इन्क्रीज केली. दॅट इज गिव्हन डेटा. Given data is F dash equals to F plus 9 hertz. And also tension have been changed to T dash. So T dash equals to 0.69, or you may call 69%, means 69 into 100, okay, of T plus original T. म्हणजे हा टी आपण कितीही चेंज केला तर 0.69%नी आणि 69%नी आपण चेंज केला. सो न्यू व्हॅल्यू ऑफ टी डॅश इक्वल्स टू 69 upon 100 into T plus T. ठीक आहे. Now all this is given data, and as per given data you could write here F dash equals to 1 upon 2L square root of T plus 69 upon 100 into T. T increase केला 69%नी upon M. ठीक है. First equation is for fundamental. Second equation by having a given data. But what is F dash? F dash is F plus 9. F plus 9 equals to, okay, 1 upon 2L square root of, how much it will be? It will be 169 of T upon 100. Obviously upon M is there. ठीक है. Call this as equation number 2. Now take the ratio of 1 and 2. काय केलं बघा, टेन्शन कितीने इन्क्रीज केलं तर 69% ऑफ द ओरिजिनल प्लस टी होताच तिथे. ठीक आहे. एफ डॅश कितीने चेंज केला तर 9 हर्ट्सनी चेंज केला. ओरिजिनल फ्रिक्वेन्सी आपल्याला कॅल्क्युलेट करायची आहे त्याच्यामध्ये 9 हर्ट्स ही ऍड केली आणि त्यावेळेचं टेन्शन सुद्धा चेंज झालेलं होतं, फक्त लेंथ ही कॉन्स्टंट आहे. अँड व्हाईल टेकिंग द रेशो मास पर युनिट लेंथ, that is not affecting, that is same, L is also same. So while taking the ratio of 1 and 2, you can write here F upon F plus 9 equals to, काय होत बघा, रेशो घेत असताना व्हॅल्यू विल बी square root of T as it is upon T into 169 upon 100. Okay, 169 upon 100 into T. Okay, so we are having this as ratio of two frequencies. F is directly proportional to root T. F plus 9 is directly proportional to T into 169 upon 100. So taking the ratio, so what you could write, that is F upon F plus 9, F upon F plus 9 equals to TT will get cancelled. So we can write 100 upon 169, and 100 upon 169 equals to 10 upon 13 square root now 10 upon 13. So F upon F plus 9 equals to 10 upon 13. Okay. So 13F, therefore 13F equals to 10F plus 90. 13F minus 10F, that is 3F. 3F equals to 90. Therefore, F equals to 30. Unit will be hertz. Okay? So the answer is F equals to 30 hertz. So this is the correct answer. Okay? How we obtained this? We have written two equations, one for fundamental mode of vibration. When the frequency has been increased from F to F plus 9 hertz, and tension is increased by 69% of the original tension, then it will become 69 upon 100 plus T, 69 upon 100 into T plus T. Okay, then we obtain two equations, one is for original, another is for changes as per the given data. And taking the ratio and solving that, you will get the frequency of vibration, that is F equals to 30 hertz. Okay. Now, next one. For formation of beats, two sound notes must have. Beats came up from Buddha. Two sound notes must have nearly equal frequencies and equal amplitudes. And this is the correct answer that we have seen for the theory. What is that? For formation of beats, two sound notes must have nearly equal frequencies and equal amplitudes. Then only beats can be formed. So answer is D. Next one, n number of waves are produced on string in 0.5 seconds. This time is same. Okay, so no need to convert it. N number of waves are produced on a string in 0.5 seconds. Now, the tension in the string is doubled. टेन्शन काय केलं, डबल केलं आणि लेंथ आणि रेडियस कॉन्स्टंट ठेवली. ठीक आहे. सो हाऊ मेनी नंबर ऑफ वेव्स विल बी प्रोड्यूस्ड in 0.5 seconds for the same harmonic? N number of waves are produced. But if the tension is getting doubled, then what will be the number of waves produced? ठीक है. For n number of waves, tension equals to T. Tension is T. N number of waves, tension is T. For how many number of waves, tension will get doubled. Tension in the string is 2 times T. You have to write two equations, one for fundamental mode of vibration, F equals to 1 upon 2L root of root of T upon M, F equals to 1 upon 2L root of T upon M, and second is for F dash when tension is doubled, okay, so 1 upon 2L root of tension double kilo, let 2 times T upon M, and here T equals to 2T that we have substituted. Therefore, how it affects on F dash, so F dash upon F equals to 1 upon 2L root of T by M, that is going to cancel. So simply it is left with F dash is equal to square root of 2. F dash is equal to square root of 2. Okay? So F dash is to F equals to F dash upon F is equal to square root of 2. That means F dash is equal to square root of 2 into F. आता इथे त्यांनी n वापरलाय, n number of waves. मग आपण f is to be replaced by n. Therefore, f dash is to be replaced by n dash, or you can say n dash equals to square root of 2 into n. N dash equals to square root of 2 into n. N is what? Original number of waves. N. And n dash is number of waves produced if tension in the string is doubled. So this is the correct answer. B equals to square root of 2n. ठीक आहे. जर टेन्शन आपण डबल केलं तर त्याची जी फ्रिक्वेन्सी असेल ती स्क्वेअर रूट ऑफ 2 टाइम्स ही डबल होते. ठीक आहे. नेक्स्ट, the equation of sound wave, it is given. What is given? Given is y equals to 0.0015 sine of 62.4 into x plus 316 into t. Okay, and what you would find? You would find the wavelength of this wave is you would find lambda. We have standard equation y equals to a sine of kx plus omega t. But what is k? K we can express in terms of 2 pi upon lambda. Okay, so comparing given data with the standard equation, we can write what is the value of k? A equals to 0.0015, kg value, kg value 62.4, omega value 316. Okay, so here k equals to 62.4. But we know that k equals to 2 pi upon lambda. Therefore, lambda equals to 2 pi upon k equals to 2 pi upon 62.4. And if you are calculating this, then it is coming as Pi t value 3.142, 2 into 3.142, okay, so divided by 62.4, so it's a zero point 0.1, whatever meter unit, maybe in centimeter or meter. So lambda equals to 0.1 unit. So this is the correct answer. What we have, view the equation of sound wave. Y equals to A sin of kx plus omega t. So as per that, comparing, we will get A equals to 62.4. And as per the known formula, A equals to 2 pi upon lambda, we are able to calculate lambda t. Simple. Next one. The pitch of the whistle of an engine appears to drop to 5/6 of original value when it passes a stationary observer. If the speed of sound in air is 350 meter per second, then the speed of engine, how much it will be? This was asked for MHT CET 2015. The pitch of the whistle of an engine appears to drop to 5/6 of the original value. Okay. What is given here? Given data. Given P equals to 350 meter per second. Original frequency is N. Original frequency is N, and observed frequency frequency observed frequency is N dash. What is the relation between N dash and N? N dash upon N equals to 5/6. N dash कितीने ड्रॉप झाला तर N dash ची व्हॅल्यू 5/6 नी डाऊन झाली ऑफ ओरिजिनल फ्रिक्वेन्सी. N dash equals to 5/6 of N. ठीक आहे. Next. Let us assume that N dash upon N equals to 5/6. ठीक है. But we know that N is directly proportional to V, velocity. V equals to N lambda. ठीक है. So we can say here N dash upon N equals to V upon V plus V. Velocity कितनी change होती है ऐसा अपन assume करते हैं, तो B इतने value में change होती है. N dash equals to N dash upon N equals to V upon V plus V. ठीक है. What is N dash upon N? That is simply 5/6. 5/6 into V plus V equals to V. N dash upon N equals to V upon V plus V. What is V? V is the change in the speed of the engine when the original frequency is dropping to 5/6 of its original value. So 5/6 into V plus V equals to V. And if you are solving this, you will get here 5 by 6 into V plus V equals to V. Therefore, V plus V upon V equals to 6 by 5. V plus V upon V equals to 6 by 5. बरोबर? V plus V आणि हा V इकडे इथला 6 by 5. So V upon V plus V upon V equals to 6 by 5. It's a 1 plus V upon V equals to 6 by 5. Okay. That means V upon V equals to 6 by 5 minus 1 equals to equals to 6 by 5 minus 1, that is 1 by 5. It's a V upon V. Okay. So what is the value of V here? V equals to this 5. V equals to 5. Okay. V equals to 5V. Means V equals to V upon 5. V equals to V upon 5. What is the value of V here? V equals to 350. 350 upon 5 equals to V. That means what is the answer here? That is simply 70 equals to V. So if the speed of sound in air is 350 meters per second, then the speed of the engine, that is the value of V. Speed of the value is changing by 70 meters per second. 70 meters per second. And this is the correct. V equals to 350. It is given. Original frequency is N. Observed frequency is N dash. N dash upon N equals to 5 by 6. N dash upon N. N is directly proportional to V because V equals to N lambda here. N dash upon N equals to V upon V plus V. What is V? Change in the speed of the engine. Okay, change in the speed of the engine. And if you are solving this by substituting N dash upon N equals to 5 by 6, then you are getting the required answer. That is B answer. This is the correct. Next. Okay. In Sonometer Experiment, the bridges are separated by fixed distance. The wire, which is slightly elastic, emits a tone of frequency N when held by tension T. If the tension is increased to 40, what is given data for fundamental frequency F equals to N, it is given, and at that time T equals to T. Then what is F dash or what is N dash if T equals to 40? Simple. What is the formula? Formula is simply F equals to 1 upon 2L root of T upon N. T upon N. F dash equals to 1 upon 2L root of T dash upon N. What is T dash? T dash equals to 40. Therefore, F upon F dash, F upon f dash is equal to root t upon root of 4t. That means f upon f dash equals to 1 upon root 4. So f upon f dash equals to 1 upon 2. That means f dash, f dash is equal to 2 times f. Here they use the notation of n. So f dash can be replaced by n dash. N dash is equal to 2 times original n. So n dash equals to 2n. Simple formula. F is directly proportional to square root of t. F is directly proportional to square root of t. F dash is directly proportional to square root of 4t. Taking the ratio, okay? Taking the ratio and converting this frequency notation in terms of n, you are getting the required equation that n dash equals to 2 times n. 2 times. And this is the correct answer. Okay? So, we'll stop here. I will share this PDF with you. There are a number of problems. You try to solve those problems. Okay? And if any query is there, you please approach me for your doubts. I will share this PDF with you. Okay? Thank you very much.